And Lmod is this little project that has consumed a good deal of my life for the past 7.5 years. So what is it? So what I want to do is I want to talk about what is Lmod, why you might want to use it, what's the differences between Tmod and Lmod, and I'll explain what Tmod is when I get there. What's new with Lmod? I would like to talk about how could Lmod possibly work, conclusions and future projects. Okay, so what is Lmod? It's a replacement for the original system, the environmental module system. I call that Tmod just so it's easy to say and easy to talk about. It's a modern replacement. It's the guiding principle of modules are to make life easy without getting in the way. And the reason why we use modules is because this is how we, as administrators, we communicate with our users. Why you might want to use Lmod? Well, it's got the same interface as the original system. It's close, not exactly the same. It's got active development, frequent bug fixes and releases, a very vibrant community. It's used all over the world. You can enjoy lots of new capabilities without changing a single module file. You don't have to install it yourself, although I kind of like to get the latest, but there are Debian, Fedora, and Brew packages available. And there's more advantages when you're ready. And it's what we and many sites around the world use every day. The features are, it reads the original TCL modules and well as Lua module files. There's a little more power available in Lua, but it's only a couple of things that you can't do in TCL. The one name rule, which I'll talk about more later. It supports a software hierarchy. That means that you can have core modules which load a compiler. You load the compiler, it provides all the modules that are built with that compiler. You load an MPI, you can now see the libraries and possibly applications that are dependent on that particular compiler and MPI stack. So this way you only see the modules which are compatible with the compiler and MPI that you've chosen. Lmod provides what I call a spider cache. A spider cache is essentially walking the system module tree and remembering it in a single file. And that is a lot faster. Lmod can read, because it's Lua-based, and Lua can read in a single file very quickly and process it. And that's much faster than walking the directory tree. So you can get fast module avail via an optional module spider cache. And you can also, if you're willing to make sure the spider cache is always up to date, you can have faster module loads. You can add in properties. You can say that this module is built for GPUs or mics, or it's experimental or deprecated or tools, or whatever you want to, whatever properties you want to give it. You can give as many different kinds of properties, and they go with the modules, and you can find out through module avail which properties the module has. Lmod stole the notion that Python has about loose versioning, so it has semantic versioning. That means that 5.6 is older than 5.10, so you don't have to worry about this problem with Tmod, where since the 6 is a bigger number than 1, 5.6 is considered newer than 5.10. Lmod does that, and it's got a very the scheme that's in Python is very clever, and I just re-implemented it in Lua. Another nice thing that Lmod provides is this notion of family. So it's kind of like family is a way of doing kind of like conflicts, but instead of having to remember that conflicting with a particular module, you essentially say I'm a compiler, and you only get one of them installed at a time. you try and install one over the other, depending on how you're set up, you'll either replace the old compiler. So if you have Intel loaded and you want to do module load on GCC, you'll bump the Intel compiler out and put the GCC in. But if you need multiple compilers at the same time, and there are some people who need that, use a way around that. Although I can't conceive of a reason why you'd ever want multiple MPI stacks living at the same time. They just don't work together. Lmod, with some extra work, will allow you to track what modules are used. There are lots of other features. There's ML, which is, once you get used to, it's hard to go back. It's a shortcut for module load, module list, and almost everything else. You can have users can have collections. That means you can collect a whole bunch of modules, either what you want for your default or some other collection when you're working on a particular project. I want this version of GCC and this Python and these libraries. You can say that's a name collection, and you can load that one with just a single line. There are hooks, which allows somebody to tailor Lmod for their site. You can control all kinds of things. The way optional tracking is done is uses the load hook. So when a module gets loaded, this hook gets called, so you can then send a message to syslog or however you want to do it. There's the nag message, and this is an incredibly useful feature. In a separate file, you can control a message that goes out with a particular module and say, "Wow, this one's going to go away in 6 months or a week or whatever." Or, you're using this module, you really ought to consider using that module instead. We have found at our site that the nag message is particularly effective because it's a message that goes to those people that are actually using a particular module. You don't have to broadcast to everybody that, oh, this version of R is going away and you should be using this other thing. So as I said, Tmod is the name I give for the environment module system. I realize there are about 5 different versions of the environment module system, but the two that are really only, I think, are particularly interesting are the TCLC-based module system, otherwise known as environment modules, and Lmod. There's a couple other ones out there, but none of them are being maintained as much as Lmod. So that's Kenneth. When I showed him these slides, I said Tmod is in maintenance mode. He said I was giving them too much credit. I don't think there's been a new version of Tmod in like 2 years, and it's been a very slow development. Occasional bug fixes come out, and very occasionally. And Lmod has something like over 300 releases. Lmod has many more features. The most important thing is that in Tmod, you can do module load GCC 5.3 and 6.0, and both modules are loaded. There is no, it'll most likely work because the GCC 6.0 will be, more recent in the path and things like that. But you can have both modules loaded at the same time. Lmod has this, what I call the one name rule, which says you can only have one GCC loaded at a time. You can only have one Python loaded at a time. They have the same name, and what I mean by the short name. So in this case, the full name of a module would be GCC/6.0. That's the full name. What I call the short name is GCC, and 6.0 is the version. So you only get one name, and the different versions knock each other out. Lmod is close to Tmod, but not exactly the same. And it's really the one name rule, which is, I think, the most critical difference between Lmod and Tmod. I mean, Tmod could support many of the features that Lmod has. Certainly, things like push env and the family directive could be easily modified into Tmod, but the one name rule would be a fundamental change in the way they both work. There are some features in Tmod that Lmod doesn't have. That number gets smaller and smaller over time, but the same. So this past year, 2016 was a really busy year for Lmod. It may not seem it, but I essentially rewrote Lmod, started from scratch and started with the core routines that walk the module tree. I completely changed those and then pulled in stuff from Lmod 6 into Lmod 7. But the big change was to support what I call name version, and I'll explain what that means in a minute. And then support for hidden modules, and this is also pretty useful. This is a way to have a regular module and say you want to make it hidden for any number of reasons. And due to some pushing from my friend in Quebec, there's support for translations, and that goes so you can localize Lmod. You can also easily change a particular message for a site. And I'll talk more about that. So those are the major changes. That's what's new in Lmod 7. There are some changes that if you're running Lmod 6 and going to Lmod 7, there's a few changes you have to make. So support for module names. So originally, Lmod only supported a directory, say GCC, and a version. And that was, well, you could have a name and no version, but or the most you could have was a name and a single version string. Lmod 5 and later support category name versions, so compiler GCC 481. The depth of the category name version can be as deep as you want. You could have applications, compiler, GCC, and a version, but you could only have at most a file as a version. That was it. And when I say short name, so for compiler GCC 4.81, then the short name would be compiler/GCC, and that would be the one that would be unique. So if some site had a GCC and a compiler GCC, those could both be loaded at the same time because the short names are different. All right. So version 7 supports what I call name version. And when I mean name version, they can be of any depth you want. The number of directories that make up the name could be as many as you're willing to type in, and the number of versions can be as deep as you like. I just call it name version to give it a name. So the support for name version, well, I'll have to explain what that means. The other things are that you can set defaults through module RC. You can set defaults. So there are now 3 ways to set defaults. You can do it in the file, put a .version file or a .module RC in the file in the module tree. You can have a system module RC file, or a user can have their own .module RC file and control what the defaults are. They can also hide modules, and this is because of the major refactoring of Lmod to support name version. There was a lot of code cleanup and much better spider cache handling. Lmod 6 and earlier could get in endless loops if a user did something, had a directory reappear, and it would reconnect it, just go forever. So there's a system module RC file, which is in where you've installed Lmod, etc. RC. It's the same file naming convention that Tmod uses. You can set the module RC file to point to a file, or so those first 2 choices are the same thing, which you only get one of those system files. Then the user can have their own .module RC file, and they can set defaults, either user-based, system-based, or files. And one of the things that, one example of where a user might want to set defaults on their own is, say you've got a web services account and you want to control which version of a package you're currently using. You could say module load Python and then have this .module RC file control what version of Python you're willing to use at the moment. one out in the system, out in the module tree, then the system one takes high priority over that, and then the user takes priority over that as well. So you can also hide modules. You can put them in the module RC file or the user module RC file, and you say hide version and the version and the path to the name. So it's got to be a full name for the file. You can hide. You can be hidden from a veil or spider or keyword, but hidden modules can be loaded. So the idea here is that if you're a site that never removes a module or rarely removes a module, but you don't want your users over time to use the old stuff, you can hide it, but people's scripts will continue to work. In other words, a module load deprecated version 1.0, that will still work, assuming the module is still installed. So this is hidden modules are at least two places that they can be used. One is deprecation and one is experimental. However, you can do, as I say there, module show hidden avail, and then they become available, and they're marked with an H to be hidden. And if you've got a black screen, they'll actually show up being dim. Kenneth's the one to help me find the dim thing. It seems to work pretty well on a dark screen with the white letters or light letters, and not so well the other way around. And I'm not sure why, but the hidden modules are marked with an H, so you know that they're hidden. Otherwise, that can lead to confusion. Why? Because, so for example, a hidden module cannot be the default. You know, that's one thing I sort of glossed over. So one of the important features of Lmod, well, actually all module systems, but Lmod in particular, is the way it will choose a default. So you can have a marked default, or it will choose the highest lexicographic one, as long as it's not hidden. So I decided that I needed to mark the hidden modules, because if you saw that, you know, GCC 17 was installed, I mean, Intel 17 was installed, but you were marking as experimental or making it hidden, it would look a little strange. So I added that feature. So Lmod has moved, took several rounds, but Lmod has moved all its messages into a message file. The default is in English, and it's in the messenger en.lua. Right now, there are language files available for French, German, Spanish, and Chinese. You only get one version for English or French or whatever. You don't get variations. You don't get French Canadian versus French continent, or multiple versions of German, or, you know, Spanish in Spain versus Spanish in the New World. If there's a message that hasn't been translated, then the English will be used instead. So right now the German is complete, the French is almost complete, the Spanish is about halfway full, and the Chinese is just got a few messages, but it does work. And you can also, if you want, you can translate. You need to add a phrase to a message, or change the wording to match your site, even if it's in English. You can provide your own site translation files, and if it doesn't find it in your thing, then it'll use English as the default. Okay, good. So why does Lmod work at all? You know, we know when we were born, we learned that environments are inherited from the parent process. Changes in the child process does not affect the parent, right? So how could Lmod work at all? It's a process, it changes the environment, but when it goes away, it shouldn't be able to change the environment. So how could this possibly work? The trick is that Lmod generates text for the particular shell or Python or Perl or whatever, and then the program, or the alias for the shells module command, evaluates that text. So it's as if you typed in that text. And this is, I think, a really useful trick to know. I've used this on many occasions when I do want to change the environment somehow. It's also helpful when you're debugging modules. Some module file is giving you trouble and you don't know why it's doing what it's doing. You can run lmod cmd some shell load and the module pipe the standard error to dev null and write things to standard out, and then you can look at what's in standard out and see what the module file is generating without changing your environment. So you can do this repeatedly, and you can add print statements to the module file to see some state. I had somebody who was doing some complicated table that controlled when they were in load mode and unload mode and wanted to know what was going on. This is a good way to debug this. So one of the problems of having a program that's taking over the world is people have problems at sites that I'm not going to have access to. So I got to have some way to debug them and understand what's going on. So Lmod's done these two things to help me better understand how it's being run on your system. So you can run module -- config to report the Lmod configuration, because Lmod has many configuration variables or configuration states. So knowing what the configuration state can be useful. Even at a site, they can say how I've installed things or where is the cache file or all that kind of stuff. And the other thing is that there's this capital D option to Lmod, which will write a whole bunch of information which is indented to tell me what's happening on a load or a veil or something. And this could be helpful for debugging for me and even for sites. They can, if you get a load storm, you can see all the places where the module's getting loaded and reloaded and whatever. So this has been really helpful. So Lmod there are a few things on the horizon. Mostly, I'd like to add support for the break statement. One of the changes I made to support name version was also to make it support the break statement. Now, the break statement doesn't get used very often, but so what normally happens is when a module file is loaded, if there's some error, then Lmod doesn't produce any, it doesn't produce any set env or export statements. It just stops working and sets the error status to 1, or to false. But the break statement allows you to get to a certain point and hit a break and then just go no further. That module file quits working, but the previous states that you had continue to work. And I had to go to a lot of, go to a stack-based support. There's a few more things that have to be added. I have to remember, the problem with the break statement is every time you load a module, you have to remember the current state of the environment so that you can come back to it. So I'm not thrilled with that, that's a penalty that everybody's going to have to pay. So, or a cost that everybody's going to have to pay if I support it. I'm looking for a spider-like command to check the syntax of modules, so that you can just say, check, something like check system module files, and it'll walk the entire module tree, and check and see if there's syntax errors. Spider is designed not to report errors. And I'm also looking for things like InfluxDB to handle the better database support for the module tracking. At our site, tracking all the modules is, there's a lot, and so I'm looking for different database options. So there's the latest version is always at GitHub. A stable version is at SourceForge, and the documentation, which there's never enough, but a lot of it is there. And I'd have to say that even though Lmod is just all it's doing is changing, changing the state of the environment. But it feels to me like it's the fulcrum of which we manage our system on. Modules are how we communicate with our users, and it's at the core of how we manage our systems. So there's always a lot going on, even though all it's doing is just changing the environment. Okay, that's all I got to say about Lmod. I'll take any questions if we can make that work at this distance. Okay. Sure. Well, yeah, it's so the rules for Spider are complicated, but if you type in R, it will find the capital R's and the lowercase r's. It's not useful, but so it's case insensitive. Um, yeah, no. Now, what the only problem is that um, if there's an exact match, it prints that out. So, um, so if you have a module called capital R, well, if you have a module called capital R for the R thing, R stats or whatever you want to call it, and you have it R, then you type in module spider R, you're going to get R, not everything that has an R in it, but it will tell you that other modules might match in there. Um, but yeah, um, the it's the design of the way Spider works is sort of my best guess for what's practical, even if it's a little hard to explain, because um, the whole notion of the fact that you do module Spider and you get a list of modules, and then you do module Spider Petsy, you get all the options to Petsy, and then you say module Spider Petsy 3.7, and then you get the information about a particular version of Petsy. That was just because of the various ways that modules are named, at least at our site, and trying to figure out something that's reasonable. But yeah, it should be case insensitive, although there's some options that makes that ML minus config. Yeah. Well, that's what I'm pretty sure it's by default it's not. I don't know. I'd have to, I'm pretty sure, um,
I think the issue is if you look for a particular version, then it has to have.
yeah, see? Oh yeah, yeah, you have to, yeah, if you're looking, if you're, yeah, I can only, yeah. There's only one. There's only one that was renamed. And just so the only thing that's important is that that you have to generate new cache files. That the names of the contents of the cache files have changed. They're now called Spider T rather than Module T, and so you have to use the new tools to generate that file. And so you can have both of them loaded, but Lmod 7 is looking for Spider T and Lmod 6 is looking for Module T. And then the only other concern is that the module table, so the module table is how Lmod communicates its state between calls. And that format has changed. So collections written with Lmod 6 and earlier are readable by Lmod 7, but collections written by Lmod 7 are not readable by Lmod 6. So it's only backwards compatible, not forwards compatible. So that's so it shouldn't be a problem for most sites, except if they're flipping back and forth, or you're an administrator and you're testing between one and the other. But if you build your collection with Lmod 6, you can read it with Lmod 7. Well, different, not necessarily better. Well, because I'm not an expert in ELK, but as I understand it, the data goes out the door in 3 months. I want long. Well, you can do it. You can do anything you want. We don't run ELK at our site, and the nice thing about having a database is that anybody who has we have an account people log into, and they can run their own queries to find out what packages were being used. I don't, I mean, there's lots of ways to do it. I'm not preventing you from using ELK. I'm just, part of the issue is in my next talk is that, the database requirements of Lmod are a lot simpler than XALT. And so Lmod's a good place for me to try ideas out. It's the one I'm trying at the moment. It's a time series database, and it looked like it might be a good choice. I'm still learning about it. I haven't decided what I'm using. This is just what I'm testing at the moment. Okay. There's one more thing I want to show before I hope this is visible. I want to show that this is what this thing, you can do this ML or module load or module minus MT, and you can get what's stored in the environment. So this is how Lmod knows what state things are, where the properties get loaded in the system, and all that stuff. All right, XALT. Okay, so so I want to talk about XALT now, and it's good that this talk follows the Lmod talk because that's the way the development of XALT happened. So what is XALT? It's XALT is what we have been using, and what I'm encouraging others to use is a way to track what's going on your system. And this can be useful in lots of ways in terms of better debugging, better understanding, better figuring out what you're going to use for how you want to benchmark your new system, how you want to qualify your new system, so you can know what people are actually running. So from accounting, you know that this user used so many core hours or however you do your accounting, but you don't really know for sure what they're doing. With XALT, you can track what they're doing. It's a census of what programs and libraries and what's being run. It's running at TAC, at NICS, the University of Florida, at CALS, and other sites, and it integrates with TaxStats as a way to do performance monitoring. So what are we trying to do? I want to know what programs and libraries are being used on the system, but I want to be extremely lightweight. I also want to be able to tell people how did somebody run their system? What version, what environment variables, what was the command line for a particular program? I want to know how many uses of a library or an application, because with module data, I can tell when people load something, but not when they use it. So the module usage data tells me it could have been used, whereas tracking with XALT tells me exactly what got used. Or libraries, because I have to maintain these things and install them, and if nobody's using something, I don't have to install it anymore. And I want to be able to click this data into a database for analysis. So XALT, how it does is it runs in users. It's a module you load, or at least that's the way we install it, and it wraps the linker to enable tracking the user's exec. The LD wrapper intercepts the user link line, and it generates key value pairs and stored in a JSON file. We also capture the trace map output from LD, so we know what libraries are being used. And this is all transmitted in the JSON format to some database in a couple different ways. XALT 1 also depended on a wrapper for app run, MPI run, etc. XALT 2 no longer needs to do that. And I'm extremely happy about that, because the correct wrappers, getting the correct wrapper for MPI run, app run, or your version, we have our own IB run, and I know that UGent has my IB run, my MPI run, etc. And so getting that walking command line to find the user executable was a real nightmare, and a real maintenance nightmare. So there's a couple of different ways to do database tracking, or track transmission to a database. You can write to a file and collect it nightly or whatever. You can use syslog and use syslog filtering, or you write to syslog and use ELK, Elasticsearch, Logstash, and Kibana, or you can write directly to the database, directly from the user, does a load or a run, and it writes directly to the database. Not my favorite way, but it's the precursor of this project. Use that. I'm also looking into using RabbitMQ as a transport mechanism as well. Dealing with the Cray, we have a Cray, and dealing with the way Crays handle their syslog, it's hard to get enough information on how to work with that. So there is, and I said, there's an Lmod to XALT connection. So I got started on this project, or the precursor to this project, because I started working on module Spider to it walks the entire module tree. And the reason why that's useful is that I have a library, but I really want to know what module it came from. So I can build what I call the reverse map and go from paths to modules. I know that, opt apps, Intel 15 and Backpage 2, HDF5, some version, some lib, comes from the parallel HDF5 module of some version. we also helps with function tracking. And if a site uses Tmod, they can still use Lmod to build the reverse map and use XALT. So one of the things I've discovered is that 1 billion or 2 billion is not a very big number. I often thought it was, but it's not. So one of the issues I've been working on is dealing with the size of the database. Machine like Stampede 1, which has over 6,000 nodes, generates a lot of data. And so I've had to deal with the ever-increasing size of the database and working on ways to handle this large size. I may not be big data, but I'm big for MySQL databases, which is what I've been using. So one of the things that, tracking environment variables are important, but I mainly want them to, so I can say, hey, here's the environment that you had when you ran this job. But it's been rare for me to want to know, well, there are a group of environment variables that get tracked automatically and they get put in a special place. Things like the number of threads, number of tasks, NUMA control, and other stuff like that. But very few of those things I need to do database searches on, how many people had this value for their prompt is not a thing I usually need to know. So I only need a few of these, few variables. The size of this database here, this join run, is the storage of all the environment variables from all the jobs. And that got to, over 2 billion, which means I ran out of space because I was using a signed integer as the index, and that means I can't put any more in that table. Anyway, so I'm storing the environment as a complete, just a compressed blob, and then have ways to filter it so that I can cut down, instead of being on average about 250 environment variables per job, get it to 20 or 30 or even less. And the filter is site controllable. So I'm looking into ways just to handle, the join tables are really large, and I'm looking at ways to try and do a better job with that. One of the problems with XALT and Lmod, for that matter, although Lmod has an easier time of it, first of all, was UTF-8 characters. It took me a long time to figure out how to get Python to do this right. And then wanting to protect the database from user things, I switched XALT to use prepared statements so that you don't get somebody having Johnny drop table semicolon and drop your tables, and also to support UTF-8 characters. I discovered that, to my horror, that you can actually name directories with non-ASCII characters or non-7-bit ASCII characters, which just anyway, in Texas no less. So, but one of the things I've discovered using XALT is that Python is a poor choice for protecting yourself against users. I don't know that it's completely possible to do that. There may be a way, but I sure didn't find it. And also for speed issues, I decided to switch from using Python to C++. So I want to control the path and the programs that run, that they be independent of whatever the users are doing. But one of the things that makes doing things hard-coded is that you probably need to do a unique install per operating system, because certain programs don't end up in the same place. Switching from Scientific Linux to Red Hat, the base name might not be in the same place. Okay. So we've been very successful at using this, and I'm always surprised that somebody comes to my office and says, "Hey, we need to know this about what we're doing." So one of the things that we had a case where there was a chemistry code where people were not they were running out of memory, and this is on Stampede, which had 16 cores per per node, and that means they would have 2 gigabytes per task, and they were running out of memory, and so they were sending their jobs to a place we call the large mem node, where there's 1 terabyte per node, but we have very few of those, and the queue times went from 2 days to 4. And so we started looking at those jobs, and between TaxTest and XALT, we were able to show that A, what the jobs were, and B, that they didn't need to run in the large mem queue. They just needed to use, instead of doing 16 tasks per node, they needed to do 8 or 4 tasks per node, and then they could fit their jobs in and get much better turnaround than trying to be in a large mem node, large mem queue. So as I said, we originally only tracked MPI jobs by hijacking the MPI run, but now we use an ELF binary format trick to track jobs. Turns out that there are things built into ELF. There's this thing at the bottom where you can say add to the init array or the fini array. You can add a program in, and so you can have something. The init array gets run before main, and the fini array gets run after main, and so you can put start the time of the job, end the time of the job, put things in here so that they run with the job. And we since we hijack the linker, we can put that code directly into user code, or we can also use it with LD preload, and we're using both, so that if the user sets LD preload to do something, we can still capture the data, or if something was built with XALT not in there, we'll still get many of the things that are tracked. All right, I'm running out of time. There are a few issues about, we only track task 0 jobs, so if you run MPMD, you've got an atmospheric and oceanic code running at the same time, we're only going to get one of them. So one of the challenges or the advantage of XALT 2 is it tracks everything. The bad thing is it tracks everything. So I usually don't want to track moves and copies, etc. So I only want to track executables that are on the compute nodes, and don't want to get overwhelmed by the data. So the answer is that we can control what jobs we track, and based on their path, we can control what executables and what things we want to ignore. Things like, I don't want to really know the configure jobs for AutoComp or CMake. I can ignore those, but these things are site configurable. And we've got do this by path filtering. So we run an accept test by ignore test. So 2 files containing, so there are files containing regular expression. This is converted to code, so it's really quick. And so you can say, well, I'm not going to track everything in user bin, but I want to track DDT or tar or something. And otherwise you can ignore certain directories. And we've spent a lot of time hardening XALT 2. We've been running it 4 months on our system here, and we've only had 1 ticket with it. One of the things that I've been concerned about is what I call launcher jobs. We have a tool we call Launcher, which is how we do embarrassingly parallel stuff, parameter sweeps and stuff. And some of those might be really short. So XALT startup times of a couple seconds on an MPI job is just not worth worrying about. But launcher jobs might be really short and just run lots of them. So I spent some time trying to minimize the amount of time that adding XALT adds to things. So it turns out that the most expensive operation was doing the SHA-1 sum of the shared libraries. And it used to be that we'd do a system to SHA-1 to call it, and we called it serial. And so I brought that into the program, and now up to 16 threads. Well, 16 is the most I will allow. It's obviously controlled by the number of cores you have. And the tests show on a Lustre file system that it might take a second the first time, but that's a Lustre issue. But if you do run it repeatedly, you get Lustre caching. it takes 0.04 seconds. So I'm, I feel like I've got it down to be almost not noticeable. For time, I'm not gonna show the demo. Again, there are the, here's the Lmod locations, and XALT can be found at GitHub or at SourceForge, and there's an XALT read the docs. So I'll take questions. Well, I said Koust and Koust and us and Nix and University of Florida are the biggest ones I know. Yeah. Well, the main thing coming forward is just trying to. I'm looking into various ways to handle the huge amount of data that comes out of XALT, especially with XALT 2. I'm going to be tracking. So what I discovered that I was getting about 70. Our charge unit, what we call an SU, which is a core hour, that I was getting like 70% of the core hours, but about 50% of the jobs. So by only capturing MPI jobs only. But with XALT 2, I'm going to be collecting a lot more data. So I'm really worried about the stream of data. So I'm really looking at different ways to do the database. But that's that. And also I'm looking to do things like, for us, you have to build and run with the same set of modules. At least with MPI and the right MPI and compiler modules. And I'm looking at ways to integrate that into XALT to make sure that I can optionally report those kind of errors. And because I store when you link with XALT, the XALT version of the linker or the wrapper, it actually stores the modules that you built with in the actual executable. And so that can be used to compare with what your current environment is. So I'm looking at things like that and just deal with the amount of data that comes out. Yes. I think he's actually doing, in part he's doing more and in part he's doing less. They have gone after hooking into actually the LDD, well, sorry, not LDD, the DL stuff. They've actually hooked there, as I recall, it hooks into, so it knows the dynamic stuff that's, dynamic library. So I only know currently what's being loaded, what was linked through, what you can see with LDD. I don't know if you have a package, which is a program which is dynamically linking the libraries, I won't see it. The other thing I am looking into is tracking things like Python or R. I'd like to know what modules are being used with those. So those are, again, now with Python, I know there's a way to add hooks to the import thing. We're looking at also doing that for R. And OGRT does things differently, and they're not as interested in the long-term data analysis as we are. At least that was the stuff I've seen with him. But I'm a year or two out of date.